Awesome. Welcome, everyone. Wow, I think people are pouring in. That's amazing. Hello, hello. Welcome to this webinar. We're going to give it a couple of minutes so that people arrive, but we see we're well past 120 people already, so that's fantastic. Welcome to this first on our new series on data ingestion, managing CAD, BIM, and point clouds. And feel free to let us know in the chat where you are dialing in from. We have a global audience, I'm sure. It would be nice to know where you are joining us from today. Ooh, Argentina, amazing. Japan, Finland, New York. Yes, I got my cap, my New York cap. Excellent. South Carolina, love it. Oh, Germany, of course. Czech Republic. Copenhagen, yes, one of my favorite cities in the world. Oh, Singapore, love Singapore. Amazing, amazing. Welcome, welcome. Ooh, some friends from Brighton. And London, of course, yes. Mexican living in the UK. That's a good mestizo. There we go. Really nice supermarket in near Houston. Oh, Gothenburg. Yes. Hello, Sweden. Amazing. Right. I think we can start. And I'm going to go through first the legalese for this webinar. We have a safe harbor statement. Why do we have this? Because Simon and I are going to talk about some products which haven't been released yet. So we need to make sure that you understand that these are not officially products. So you shouldn't base your business on them yet, or at least your purchasing decisions on these. And things might change as the product gets released later. And today, we're going to start with a quick introduction. So I am Jérôme Moret-Delaunay. You may know me from Road to the Metaverse, which we did last year and the year before. I'm a senior solution consultant on the industrial team here at Unity, working with European customers and helping them onboarding Unity for their solutions. I am based in London, and I am joined today by my dear colleague, Simon.
Thanks, Jerome. It's a pleasure to be here with you. So I'm Simon. I'm Simon Nagel, located in Munich. I'm senior solution consultant. So I have the same job role like Jerome. Probably my focus is a bit more different. My focus is more on high-end visualization, on the design side of things. I'm also focusing on real-time 3D since some time. And I'm working with the automotive industry for some time now. I used to work at Autodesk for 10 years before that. And back in those days, I was in the creative world of creating digital content. And I'm happy to talk about how this all can be done with Unity today. Rebecca, who are you?
Yes, hi everyone. I'm Rebecca Mwanja, and I am part of the Partner Relations Management team here at Unity. I'm based in Brighton, and I've been at Unity for now approaching about 2 years. But in a previous life, I was an architect of buildings, not code. And also have an associate artist certification from Unity. So yeah, I'll be going through industry success and what that all includes.
Fantastic. Thank you, Becca. All right, housekeeping, some rules. This session will be recorded, so don't worry if you have to drop off early. You can catch up on the recording, whatever you have missed. This session is moderated. We have moderator on hand, so we'll be reading the Q&A and the chat. So be kind, right? Be respectful. We never had to boot someone yet, at least on the sessions that I've been included in. So let's keep it that way. Technical and session-related questions go into the Q&A pod. You have a Q&A button in your Zoom interface. Use that to ask questions so we can find them later, or ask them as we go along the session. And also your thoughts and comments can go into the chat, if you want to keep it lively. But we'll appreciate if you can pay attention also and follow along the content that we'll be presenting today. This series is a new series, as I mentioned at the beginning, focused on industrial creators. So this is really non-game and assumes, that you work in industry sectors, as Becca mentioned, whether it's architecture, manufacturing, facilities management, or, for example, training, right? And you'll cover use cases afterwards. We're going to cover some of the key topics. It's 4 episodes for this year. We have data ingestion today. We're going to do collaborative workflows next, which will be in June. We are going to look at creating experiences, so that really bringing together both assets and behaviors, writing code, etc., for building amazing experiences in Unity. And then finally, we'll look at multi-platform, multi-device development with Deploy Anywhere, the last episode, which will be all the way in December, but hopefully, that's going to come really, really quick. So no worries. These are live sessions, so we're trying to keep them interactive. Feel free to ask questions, and we'll try to answer them live or at the end in the Q&A section. We'll try to give you as many tips and tricks for onboarding you with the new features and data sets, or features and services that we provide. And finally, we'll help you discover a little bit what every tool does, also avoid pitfalls. And as I mentioned, it's live, so ask questions, and we'll try to answer. The agenda today is pretty simple. We're going to start with, actually, we're already in the introduction phase. Then the main workshop is about an hour, and we'll be covering managing data in the editor. That's Simon that will be presenting that to you. Then I'll do a little section on using the Pixies plugin, which is a Pixies integration for the Unity editor. We'll go into data ingestion using Pixies Studio and Pixies Scenario Processor. And then finally, we'll close off with a new product, Pixies SDK, which will be released soon. We'll have time for Q&A at the end. We'll take as much time as we can, and also next steps and wrap up afterwards. So, bit of introduction. We're here today because of Unity Industry. Unity Industry is a new product that we released last year, which is focused on our industrial creators. It's Unity Enterprise. That's something that's already available as part of our licenses for Unity of editions, right? But it also bundles the Pixies plugin that allow you to ingest specific data formats more aligned with what our industrial customers need. And finally, a big component of this is industry success, which includes technical support, on-demand training, and obviously customer onboarding to help you get the most of the tools as fast as possible. There's also a generous cloud bundle with this offer, some specific actually features which are only available to industry customers, including special tier of the asset manager, and obviously team administration, just like we other cloud tiers, and DevOps allowance also. And finally, like every single paid edition of Unity, it allows you to build and deploy to the Apple Vision Pro if you're so lucky to have a device already, or looking forward to start developing as fast as possible as you get your developer device. And now I'll hand off to Becca for presenting industry success.
Awesome. Thank you so much, Jerome. So let's just do a quick overview of what industry success is and what's included as part of it. So industry success is available to everyone who has an industry subscription. So if you do have one already, please make sure to check out what is available to you, which includes an industry success package. So what it entails is you have firstly an assigned PRM. So that will be me. So that would be someone who is an advocate for you, who's here to talk to you about project-related things. On top of that, you'll have a product activation service. So what that is we understand that with industry, there's different network settings, network infrastructure, and security settings. So we have a team that's here to help you, to work with you, and to make sure that you've got everything set up and you've got license access. On top of that, as your PRM, we do check-ins. So we check in on you on the quarterly to make sure that you are okay and that you're using Unity to its most advantage. But we also do an onboarding for those who are starting from scratch, but also just to kind of check in as well. If you are a seasoned developer, we still want to just make sure that you have access to everything you're entitled to. In addition to our kind of like success package, we've also got technical support. So with industry, you'll have a 48-hour minimum SLA, and that's our team kind of getting back to your technical tickets within our portal. And you've also got on-demand training. So this is to kind of help support you with your development, to support your team. And these are kind of like curated courses that you can kind of dip in and out of whilst you're developing. So just to kind of like deeper dive into how we're kind of like working within your support team. So as your PRM, like I said, we are your point of contact. We're also your advocate. So we're here to kind of hear your feedback, to hear your pain points, and to make sure that your kind of any feedback that you have is listened to and heard, as well as being your strategic partner. So like I said, we're mostly project related. We want to know how you're using Unity, and we can then best support you and provide advice to make sure that you're successful. And that's really our mantra. That's our main goal. We love it when our customers are successful. We love it when you guys make really cool applications, and we're here to support you. And just a kind of overview of what we do cover in terms of the industry side of the Unity business. So like I said before, I used to be an architect, so we do cover kind of AEC, but we also have automotive and aerospace customers, manufacturing and automation, so kind of inside a factory, big massive CAD data. We also have customers working in the retail space and commercial, as well as in smart cities and in energy applications. And what they're making. So they are kind of a big selection of different applications, which are kind of being created within all of these sectors. So immersive training is kind of one of our growing sectors at the moment, because it's just super useful and it's super accessible for a lot of users. But also we've got XR, and of course, following our recent collaboration with Apple Vision Pro, we've got Polyspatial. We've also got the collaborative viewer, which is really great for kind of maximizing kind of collaborative design reviews and validation. So making sure that you're kind of checking out for problems before you actually build things or put things on site. We've also got HMI, which is really kind of maximizing our real-time 3D capabilities and functionality, and letting you actually interact with machines in real time. And of course, we've then got our immersive customer experiences. So that's really kind of using Unity's visualization tools, our simulation tools, to really kind of immerse your end users, your customers, within your kind of 3D models and data. And so just as this is the first in the series of webinars, I think for this section, just kind of like a little bit of tips and tricks from our partner relation team. Please do reach out. We are here to help you, and we're here to listen to you. So if you kind of are thinking about getting hold of an industry license, we've got a link here that you'll get in your kind of follow-up. Just contact us. We want to hear about your specific needs, especially just to make sure that we are providing the right success package for you. In addition to that, if you do already have an industry license, yay, then please contact your PRM if you haven't done so already. We are here and you are all assigned one. If you do feel like you've not really received any communication about a PRM, please also do check with your economic buyer or your reseller, and they will have an email with our details. So just double check on that and get in touch with us. Cool. So now I'm going to pass it over to Simon, who is going to give us an introduction into data ingestion.
Thanks, Rebecca. Let's get into it. I mean, you probably know that Unity comes from gaming, but Unity also is in use in the industry. And obviously there are similarities and differences in both of those worlds. However, for all of the use cases that our industrial customers work on, we kind of see patterns like how to achieve that goal using Unity technology. So there always is a need to ingest industrial data, where always is a need to collaboratively work together. There always is a need to create some kind of experience. Might it be like a training or an XR experience, a collaborative viewer, an HMI experience. And at the end, you need to deploy that output. That is why we chose this webinar series to be not use case specific, but workflow specific. So today, we will take a look at data ingestion and the different technology stacks that Unity offers. But before that, I would like to ask a question to all of you, and probably we can start the poll. I mean, which of those file formats that you currently see, you see the most? So is it FBX? Is it mainly CAD data? Is it BIM data? Are you coming from the AC space? Are you working with point clouds? Are you working with USD? And obviously, you can check all of them. If you're working with all of those data, just check all of them. That's technically what I do.
There are no wrong answers.
But I'm not allowed to.
For people on the recording, you won't be seeing this poll, but we'll share the results afterwards. No worries.
Okay, perfect. So, all right. So pretty much everybody's working with Unity and with FBX. We have many CAD people, great. So we have many people coming from the industry, BIM, perfect, cloud. USD, okay, that's surprising. I expected this number to be higher. And it's great to see that GLTF actually is used by a third of everybody as of today. So we will cover all of those formats later during the day. And we would like to answer the overall question, how to work with data in Unity tools and how to manage CAD, BIM, and point cloud data. So let's start about data ingestion into the Unity editor. And my next question would come up, don't worry, it's not going to be like a question per slide, but how familiar are you actually with the Unity editor? Who do we talk to? It's like, yeah, heard of it, but never really used it. It's like, yeah, I'm intermediate. I have some experience with it, like advanced. I'm very familiar with the editor. I use it regularly. I'm just watching the sessions, and I'm pretty confident that I can repeat everything tomorrow. So I think we leave it open for probably a couple more seconds.
Becca, what's your level of confidence with the Unity editor?
Good. All right. I can function.
All right.
I know where the buttons are.
Amazing.
Perfect. So we have a pretty good mix, pretty much even spread it. Could say like a third, a third, a third. But the majority is advanced use of Unity, which is fantastic because we are sometimes going a bit deeper into the technology. So hopefully we can add some value for you that you go out of the session and say, okay, there are some things that I learned from today. We clustered this session and start with data ingestion into the Unity editor first. There's so much to talk about. So we reduced it to 5 foundational facts, how to work with data in the Unity editor. Number 1, and 40% knows this quite clearly, right? Projects in Unity are file structure based. And you might say, well, sure. I mean, what else? Well, the workflow in Unity is project-based because the goal of Unity is to create an experience, and an experience is more than just one file or one scene. An experience usually is a collection of assets, and those assets always need to be stored in one project. And this one project needs to be stored in one specific folder on your hard disk. So Unity offers templates to create those projects, depending on what you want to do. So why is it actually important? It is actually more important than you might think, because data always is part of your project. So let me show you. In the editor, you can see all data of your project in the project window. So you can see the folder structure also in the Windows Explorer, which means if you create something in your project, you also see that the data will be created in Windows Explorer. The other way around, this also applies. If I create a text file, for example, in Windows Explorer, I see also that it pops up in my project. It's also working the other way around. If you delete data, may it be in your project or may it be in your folder, that data is gone. It's gone forever. So you really delete it from your hard disk. Also, if you move data away from your project, if you want to read it in another project, then it's also gone for your project. So whenever you import data from another location, you will always copy the information into your project of the Unity editor. So you are losing, by default, the connection to the source destination. Of course, you can set up workflows that we can have a reference to those files, but by default, that's a setup. And that's something which I needed to learn after coming from DCC tools, where we usually work with referencing files. Fact number 2, Unity can import 2D and 3D formats from DCC tools. So Unity is designed to work with common formats from the digital content creation industry. So it natively can support different 3D formats like FBX, but can also natively import data from Maya or Blender. However, please make sure that the software is installed on your PC. And if you share the project, just tell your colleague that he should install Blender or Maya on his PC also.
Ooh.
Once a file is added into a Unity project, you can see file-specific options to make adjustments to that file. So for example, I can make adjustments here, and afterwards I can move my file into my Unity scene. And now I can make adjustments, for example, a remapping of some material. And as those adjustments are made to the file, the changes will affect to all scenes in which my files are used. So if a file is part of a project and modifications are applied to that file, for example, if I work with Maya at the same time, and if I just change this file to the project, the data automatically updates and changes in the Unity editor. There's no manual need to upload the data. This is quite valuable when I'm working on a seamless workflow between DCC tools like Blender, Photoshop, or Maya, as I can immediately and in real time see changes that I do in my design tool. So Unity supports a large variety of formats that are standard in the digital content creation. So FBX, OBJ, obviously, S3D formats. We also support classic 2D formats, BMP, JPEG, PNG. You can work with 32-bit formats like HDR and XR and use them as skydomes, HDR panoramas. We also support GIFs. Jerome, I just added a picture for you because I know you like it very much.
Thank you.
If you import a GIF, please make sure that you can convert it like to a sprite animation to really use the animation of the GIF file. Audio files are natively supported, such as MPEG, OGG, WAV. Video files are also supported, and they can, of course, be used for just play some informational content. But you also can use video files to create fantastic real-time visual effects for illumination. Like you could simulate the behavior of an animated light texture, for example. Please be aware, the best native supported video codec is H.264. And as we also have many users who are using Unity in 2D, they were working with fonts and texts. We also support various font types as true type fonts and open type fonts and different text formats. If you want to use them in 3D, make sure to use Text Mesh Pro. Okay, fact number 3. Unity can structure and manage data in a very flexible way. So Unity handles files in your project, but you can also add your files to your project and afterwards add them directly into your scene. So every node of that file will be represented as a so-called game object in Unity and can be accessed in an individual way. Like it can be hidden or shown or moved and so on. And those game objects don't much do themselves, but they have so-called components. And these components take care that, for example, that the mesh is rendered in the right way, that the mesh has a material, and so far and so on. You can also use those game objects to structure your scene. So you can actually change the hierarchy by working with game objects. A very unique feature of Unity, and Unity users love that feature, are so-called prefabs. And prefabs allow you to store game objects with all its components, values, and children. So they kind of act like mini scenes. And so if you would like to work with a certain configuration of an asset, you can save them as prefab and deploy those assets later on in the scene. And those prefabs are designed to be efficiently handled in your scene. So they're performing quite well as they're sharing most of their properties. However, you also can make adjustments to prefabs, to individual prefabs, and you can also apply those prefabs that they are applied to all of the same prefabs in your entire scene. So working with prefabs allows you lots of flexibility in the setup of your project, and working with the hierarchy also allows you to manage complex data sets in an efficient way. Number 4. With packages, you can do anything. And technically, well, we heard a customer saying with Unity can do anything, but actually packages really make this possible. So the question is how? Well, you can create so-called packages for Unity, and a package contains features to fit the various needs of a certain project. So for example, from Unity, we provide core packages that are bound to a certain version of Unity, like the render pipeline, HDRP. Or we also provide built-in packages, for example, for physics. Or we also release packages that you might need to enable a certain feature, like XR interaction or just a simple FBX export. However, the great thing is that everybody can create a package to make anything possible. You can find thousands of those packages in the Unity Asset Store. These are linked directly here on the site, where our community is creating packages to serve all kinds of needs. And those packages can be designed and used to create an importer to import a specific file format and can actually be created to handle the 3D data import. So let's just take a look. So packages can be authored into Package Manager. So you have an overview of what is available in your project. If you would like to add the release package, select the package in the Package Manager and install it to your project. In this specific example, I installed the PSD importer, and it allows me to work with PSD Photoshop files, so I can import its layers directly into Unity while having access and controls over overrides. So if I make a change in Photoshop, I see the change on that layer in Unity. And at the same time, I can just make individual overrides to specific layers in Unity. Great feature for Photoshop artists. Talking about artists, Substance is a common material format that is used in many DCC tools and also by our customers. And Adobe created a package for Unity that can be downloaded in the Unity Asset Store. And once this package is installed, it allows to natively import SBSAR Substance materials, where you might have access to. Just download this as a free asset from the Asset Store. You can import it natively directly into Unity. And afterwards, you can apply it to a game object. You can adjust its properties to be rendered triplanar with another tiling. And you can immediately render it in high quality in your Unity HDRP render pipeline. So let's talk 3D. Let's talk about 3D formats. So we see some trends in the industry, and we also see which formats are used for certain workflows. And Unity is committed to increasing its adoption of open standards to help deliver a common foundation for content creation, collaboration, and interoperability. And we see two important file formats, which are USD and GLTF. So I would like to talk about them. And as learned earlier, some of you are using USD, many of you are using GLTF as of today. USD import is quite straightforward. So we just provided a new plugin a couple months ago. For this, you require the new Unity 2023.1 version. So USD is a format Unity wants to support, as we consider OpenUSD to be a complementary technology that helps users to build more powerful workflows and content pipelines. So for example, OpenUSD can be used for flexible, complex, multi-layer content authoring. So here we are loading a USD scene into the HDRP Unity example that you can just create when you create a Unity project. And afterwards, we have the ability to just walk through that factory scenario from a third person's view. And I think that's kind of one of the big values of a game engine, right? That technically just by drag and drop, it's quite convenient to review and experience large facilities in a gamified experience. The other format that you should have heard of, if you haven't, you should have heard of, it's GLTF. So you can also import this package by name. And GLTF, import and export in Unity is quite straightforward. So GLTF, which stands for Graphics Library Transmission Format, is a standardized file format used to store and transfer 3D scenes and models. It's kind of like the JPEG for the 3D world. And GLTF is gaining significantly more popularity as a 3D format with its open source nature. And GLTF also is a format which is supported by many 3D applications. It is supported inside of Unity. It also holds texture and material qualities in a very good way. That's the initial representation in the Unity editor is working quite good. But it's also a format that is running natively in a browser. So it's a format which can be shared quite easily, and it's also supported to run into Unity runtimes. So it can run in any experiences on any device. Fact number 5. Unity can store assets also beyond the Unity editor. So Unity recently introduced Unity Cloud, which is a single place where users can upload, manage, and interact with their projects. And we would like Unity Cloud to make real-time 3D projects more accessible. So, and we want to do this because we would like to address the needs of millions of our Unity users. So Unity Cloud has a very holistic view of managing 3D data because we know, well, data is hybrid. There are different tools, pipelines, file formats. The more people you have, the more problems you have. So the decision from us was that we don't want to tie Unity Cloud to the Unity editor, or we did not want to tie actually it to a certain file format. So we want to focus on real-time 3D data to create experiences. And on top, Unity Cloud can leverage Unity technology. So, well, you know the Unity editor, which obviously can benefit from Unity Cloud services. but also Pixies is used for data transformation in Unity Cloud. And also Unity version control, formerly known as Plastic SCM, is a great tech to versionize and manage data over time. So a core part of Unity Cloud is Unity Asset Manager. We're going to see it in action in a minute, which is a storage agnostic, easy to use digital asset management platform that creators can use to upload, manage, and transform, and also to share their assets in their business and also to others. So Unity Asset Manager can be accessed and used in the browser, completely independent of the Unity editor. So let's take a brief look on an overview of Unity Cloud. So Unity Cloud, first of all, offers a large variety of services. For example, there's a service for data transformation, leveraging Pixies technology. We have 3D data streaming to just stream low-poly data of complex models into a runtime. We have a cloud presence service, which provides a fast way to set up multiplayer and more. And we also have Unity Asset Manager. And Unity Asset Manager is an integral part of the Unity Cloud, and it can store data, which technically can be anything, can be a text file. But if it's a 3D geometry, it will be handled as such, and 3D previews and thumbnails will be automatically created. And those thumbnails, and also, very important, the metadata will be stored with each asset. Unity Cloud can be accessed via an SDK and can be enabled to import and export source data. From Unity Cloud, you can create real-time 3D experiences, which can be done manually or automatically, as we also can connect to the powerful SDK connection. As I said, Unity Cloud works great with the Unity editor, but it's an open platform and it can be connected to any DCC tool and any workflow available. All right, let's take a look at Asset Manager in action. So technically, in a web front-end, it allows us to upload any data, even CAD data directly. So here we are uploading 157 SolidWorks parts, and the data will be stored, and 2D and 3D previews will be automatically generated. So I have visual control over the uploaded data. So you can preview and upload your CAD directly in the browser within, I think the process of uploading 157 CAD parts to the Asset Manager took 15 minutes, including the preparation of the conversion to the 3D data and also the creation of 2D thumbnails, which I think is a pretty good time. Due to the SDK and API connection, well, you can connect to Asset Manager and to pretty much every tool. There's also a link below. We're gonna, I assume, share it later, where you can check out the Asset Manager for Blender repo at GitHub, where you can see how assets can be exported from a DCC tool like Blender to Asset Manager directly. Again, Asset Manager is open, is not tied to the Unity editor, and can be used completely independent of the Unity editor. So as a little sneak peek, and it's an open beta right now, we also will provide and offer an Asset Manager directly into the Unity editor. So this will allow you to access your files even quicker, and in a centralized location, which can be accessed by everybody in your team or your ecosystem. And when working with it, I got really excited about the quality, about the GLTF materials. So for example, this part here, I exported from a URP scene. I mean, the Unity users know like what URP is. So like from our universal render pipeline, and I imported it to our HDRP pipeline. And technically, as the shaders are interpreted in a way that is supported by both render pipelines, I immediately have a pretty good quality. So I see a lot of potential on Asset Manager, and that it can improve really daily workflows in the editor, but also it can help how assets can be loaded directly into runtimes, leveraging GLTF technology. But remember, right, I uploaded CAD parts directly to my Asset Manager. So what would happen if I now just try to import those CAD parts from Asset Manager into the Unity editor? Well, Asset Manager is file agnostic. So technically, it stores the SolidWorks parts. So by default, this is not working in the Unity editor because CAD files are not supported. But lucky us, we have access to Unity Industry, and Unity Industry comes with Pixies plugin. And Pixies plugin is another package that can be installed by name. And afterwards, your Unity Industry license needs to be activated. But after that's done, the SolidWorks parts in your scene can be imported in a proper way. So this allows me to import CAD directly into the Unity editor. And I think that's great, right? And Pixie's plugin is not only about importing, it offers a large variety of functions. And Jerome, glad you're here. And I'm really looking forward to see you now using Unity in real time and showing live some tips on how to work with Pixie's technology directly into the Unity editor. Ready to go?
Fantastic. Yes. Thank you, Simon. Splendid presentation and perfect segue. So let me share my screen. You should be seeing now my slides, and we're going to go into Pixie's plugin. So Pixie's plugin is a set of features and tools from the Pixie's API that are integrated directly inside the Unity editor. It brings with it all the file formats supported by Pixie, which is over 70 from 20 different applications. And that includes a lot of the formats that you were mentioning today, including obviously point clouds, but also native formats like VRED, CATIA, AutoCAD, LES, Revit, right? SolidWorks, all of those can be directly imported inside the Pixie's using Pixie's plugin and can be brought into the Unity editor. On top of that, Pixie's plugin also will bring the metadata from those files, including the Pixie's native files, which is a format that you can use to exchange between the various Pixie's products. But if you have a SolidWorks file, for example, or a Revit file with metadata, this will be bring into the editor, and you can use that for then displaying it in your UI, for example, if you need to show the part information, or to make decisions as far as processing. For example, determine if an object is going to be customized in any way during the import process. For example, if you're going to use some optimization algorithms, if you're going to generate LODs, so you can generate LODs with Pixie's plugin, something that is not natively supported by the editor and is very convenient for optimization. I have a slide on that afterwards. You can generate UVs directly inside the Unity editor for baking lighting, for example, or for mapping out 2D images, as Simon highlighted earlier in the presentation. And then we have a rule engine, which allows you to automate the workflow inside the Unity editor in order to avoid repetitive tasks. And we are now popping up a little poll asking you how familiar are you with Pixies? Have you heard about it before or not? And let us know. And then we'll go into the demo. All right, so while you answer the poll, I'm going to jump into the demo. I'm going to go inside the Unity editor and press play. We are live now, so embrace the chaos as usual. I have with me my trusty Xbox controller. As we said, we are a game engine at heart, so here I am just running around into a scene. I have a nice point cloud which I imported, which is a few million points. It's not massive, but it's not small either. And here I have a gate. Oops, this is a BIM object. This is from a Revit file. And obviously you can see it's physical. It reacts to the user. That does let me go, but I can jump. There we go, magic. And now I'm on the other side. We also have here a few bollards to stop cars from driving and going near my transformers. These are two transformers. They're CAD file. I believe they were DWG formats from SolidWorks originally. And they have been imported with the Pixie's plugin directly, and I can even push them around. They've been physicalized. They have a collider on them, so they react to the physics system, and a rigid body, which means I have the power to move them with my character here, something you wouldn't be able to do in real life. I see we have the results from the poll, and good. A third of you haven't heard about Pixie, so there we go. We're going to cover this today. Some of you have used, most of you haven't used it, so that's perfect. So there we go. You can see I brought those assets inside the editor, and I'm able to interact with them directly. By the way, if I wanted to, I could have physicalized also by creating a physics mesh for this point cloud. Right now, I don't have one, so I can go through all the points, but if I wanted to, I could do that too, right? Enough with this first section. Let's look how we import things inside Unity with Pixie's plugin. So I'm going to go to the start scene, which is pretty much empty. And when you add the Unity package, Simon showed you how you use the package manager to add features. You can add the Pixie's plugin to your project via the package manager, and then this menu will pop up. You can just go into import model, and I'm going to go into the assets folder here, and we're going to start with this point cloud. So this is an E57, one of the formats that's supported by Pixies. I can decide to bring in metadata. Here I have the little file importer window. There is no metadata with this point cloud, so I can untick that. I can select whether I want to keep the maximum density for my cloud or if I want to decimate it. In this case, we can keep the maximum density. And then one thing is I can override, for example, the material, but also I can decide what do I do with this asset once it's imported. I can create a prefab. As Simon highlighted, this allows you to use repeatable assets within your project. So it's nice and optimized if you duplicate that instance. Or I can just import it into the scene. The scene is convenient, but be careful as you import large assets, your scene size will balloon. So sometimes it's often better to create prefabs. In this case, for sake of speed, I'm just going to import the point cloud to show you how straightforward it is. It takes a few seconds, obviously, and there we go. I have my point cloud. It's inside the editor. I have a nice material that's provided by Pixie's plugin, which actually gives me some options as far as rendering, but it's here. One thing that I haven't showed is the segmentation. I chose a 10 by 10 grid, well, a 10 unit segmentation, which breaks down the point cloud into those chunks. Why would you do that? Well, that allows you to use what we call occlusion culling, which means that everything that my camera here, this is the frustum culling of my camera, that's what my camera sees in the world, right? And you can see that all those parts behind here are not visible. So they won't be rendered or they won't be pushed to the GPU, which means it's much more efficient. If you had this point cloud as one object, then even if two vertices or one vertex was visible, then you would have to push that whole geometry to the GPU, which is very inefficient and consumes a lot of resources.
Perfect, Jerome. You're talking about visibility all the time, which is fantastic. Some people in the chat are saying that the video quality is quite poor, so probably we can just change the share. We can just change the settings to not go for optimize.
Oh, optimize for video? Yeah, of course. There we go. Sorry about that.
Yeah, that's a lot better.
That's a lot better. Fantastic. Yes, we are working with nice assets. So let's do this. So anyway, you can see here all the parts that have been created for this point cloud automatically by Pixies. So next, let's bring in a CAD part or a CAD model. Again, I'm going to go to import. Here I have my ABB transformer, which is from a GrabCAD. By the way, that point cloud was from Sketchfab. This is a DWG. I'm going to open it, and here I'm going to have some different options because we're now dealing with a CAD asset. By the way, what I can do here is hide this in my scene view. This, for those of you who don't know, when you select an object here, you can select to hide it, which means it won't be rendered at all, or you can just hide in the hierarchy, which means it's not visible in the scene view, but still visible in the game view when you go into play mode. And I can also make it unselectable so that it doesn't stop me from working and selecting things that I don't want to select erroneously. So there's no point in there, so I don't need to import them. I can keep my hierarchy, right? So that's the product structure. I can decide to bring the full product structure, or I can clean it up here on import. I can also do it afterwards, so I don't have necessarily to do it all on import. This can be done after with the Pixies toolbox. I can merge by material, or merge all, compress everything into one object, for example. But here I'm going to keep the full hierarchy because I want it. And I am going to do a medium quality for the mesh. I don't need to go high. Simon told us that the first tessellation usually goes with medium and then we tessellate if you need to. So that's what I'm going to do. And again, I'm going to import it directly into the scene for convenience. So there we go. My DWG is going to come in. And then I'm going to select it, press F to focus, and you can see something is wrong here. I don't know what this is. Oh, there it is. There's my file. It's obviously not orientated the right way. And also I have this thing here, which I probably need to remove. It looks like it's some sort of floor. But rather than doing it manually in front of you, which would take forever, I pre-prepared a Pixies rule. So here I have my little rule, which is an asset that you create by going into the, oh, sorry about that. By going into the create Pixies and rule set right there. And then I define actions. This is all visual. You can click the plus to add various actions as you need. There's no need to code or anything. You can extend it if you want to. But here what I'm doing is I'm going to delete that floor plane called 231 here. I am going to merge the materials, my hierarchy by material. As I told you, you can do it after import. You don't have to do it before. I'm going to rotate that object so it's facing the right way. And then finally, I'm going to use the magic of create colliders to create a physics collider directly. You remember when I pressed play in the demo earlier, I was pushing that object. This is how you need a collider for this. And this is what we're going to do. So let's run this script. And you can see it's already deleted the objects, fixed the orientation, and it created a little collider for me here. I can focus on this. You'd see it's loosely following the mesh. It's not super precise, but it's nicely optimized so that it won't take too many resources and should give me the desired effect. I can just drop it into this file, and now I have a perfectly prepared model with my physics collider and my optimized mesh here into the scene. Finally, I am again going to hide this and import a Revit model. Someone was asking in the chat, does it work with Revit? Yes, it does. And by the way, I don't have Revit installed on my machine, right? I'm importing this directly using the Pixies import. So that's also very convenient. And I have two Revit files. I'm going to import this barrier here, which is from BIM object, and I'm going to use the Revit file directly and open it. Same options. I'm not going to change them. Just going to import this into my scene quickly. And there we go. Okay, this is not what we had in the other scene. BIM objects, for some reason, always come with these bounding boxes. So again, I could sit there and try to go through and figure out how to remove them. But I created a little action already just to be more efficient. And you can see here, I'm going to find all the children of the latest imported model. I can also change that with the current selection, for example, if the file has already been imported a while back. I don't have to use necessarily the last import. Find all the objects that have this material, that contain the material name render material, and then hide them in this case, not delete them like I did before. And then there's one bounding box which was remaining afterwards, and that's called mesh 17. So I'm just hiding this. Let's run this, and you can see now I have my nice little object pre-prepared. And once you have all of these in your scene, as I showed earlier, we can go back there. I don't need to save because I have this scene here. And now I'll show you once again, just for effect. Let me know, Simon, if the performance is poor, and I'll switch the screen to optimize for video. But you can see here, I'm in the scene view, sorry, the game view.
Pretty poor. Pretty slow.
Poor.
So now we have to optimize for video.
Let's optimize for video for a second. There we go. Share the sound because you can see here also the footsteps. There we go.
Much better. Jump, jump, jump. Yeah.
So as I showed you before, here you have the capability of moving that object because it has a physics collider. I can't go through this because it also has a physics collider. So this is super convenient, and you can see how quickly you can get those assets directly into Unity without using any other tooling. I'm going to cover quickly.
Can you just turn on the stats quickly? The question was asked, like once you're running through it, also we know you answered it.
Oh, yeah, we can. There we go. Let's go back. This is live. We are live, so we can do whatever we want. There you go. And I'm going to maximize again. And you can see the stats, right? As I move about, you can see how the triangles really reduce when I look at this. For example, there's only 190,000 vertices here because I'm not looking at much of the point cloud. But as I start to rotate and turn around, you can see we go easily towards 3 million vertices because now I'm looking at more of the point cloud, obviously, right? And then it goes right back down as I move about. Keep in mind that there's also the background that brings some objects and those models here. So occlusion culling. By the way, in Unity 6, this will be even faster with the new GPU-driven occlusion culling. So we're in 2022.3 because that's the latest LTS. For those of you who don't know, LTS is the latest long-term support version of Unity, which is recommended for production project. So hope that was informative. Let me switch back to not using the optimize for video in Zoom, so that the quality is better when I switch back to my slides. Right, we've been through the demo. Again, we'll share the slide after the session. So here are the links and the fantastic creators that share them. All of these are free. You can download them from their respective websites, whether it's GrabCAD, Sketchfab, or BIM objects. And then special mention to our package, by Unity, which is the character controller, part of the starter assets. You've seen it in Simon demo, but also in mine. It's a really convenient free package you can download from the asset store, drop it into your project, and then you have this character controller, which you can move about and really use for your quick demonstrations. Please use them and rate them. Right. Key features that work across the board. It's not specific to BIM, CAD, or point clouds, although you can use it on all of those when you import them with Pixie's plugin. It works with FBX files, which you drag, GLTF that you import in the editor. Whatever you bring in, you can use, generate the LOD generation features of Pixie's plugin to automatically generate LODs for you. You define the recipes or the scenarios for each LODs, including the level of decimation, so that's mesh reduction, whether you want to remove hidden objects, for example, and the level of aggressive removal that you want to do, whether it's by game objects, by deleting, for example, polygons directly on the mesh to really crunch the performance. You can merge everything together, including the materials, bake the materials, maps into a single map, so you end up with one mesh, one material, and one draw call. So very efficient way. There's a whole series of options that you have in order to create your LODs based on what you want to do. You can also use the default to get started quickly. And as you can see here, we start with 4.2 million vertices and end up with 100,000 in one mesh, right? And this is a one-click process in Pixie, so it's super easy to get started. Colliders, very important. This is my favorite demo of all times. It shows you how to work with convex decomposition. So if you have used Unity before, you know that holes in physics mesh are not supported. That will give you an error. This is what happens in the one in the middle here that just disappeared. But if you have a hole in your objects, then you want to create combine a composite, basically collider, which you can do it manually with boxes or with spheres and assembling it together yourself, which takes time and effort. Or you can use Pixies in one click to generate a convex decomposition physics object, which will take care of you. It will create multiple little physics meshes, assign them to the object to recreate the shape loosely, with the level of precision that you want to assign, and gives you the realistic fastener here on the rod, and this is working perfectly. So again, that's a feature that's applicable to any mesh inside the Unity editor, not necessarily to what you import with Pixie's plugin, right? If it's already in your project and you add Pixie's plugin, you can apply all those algorithms. And then this is possibly one of my favorites. It's the ability to move pivot points. So this has been a pain point for me ever since I started using Unity and working with 3D assets, going back to designers. I would go back to Simon, for example, and ask, hey, can you update the pivot point on this in Maya, right? Or I would have to open the model in Blender and do it in there. Other option would be to reparent the object inside Unity to try to basically realign the center and then use that parent to do your manipulations afterwards, which is time consuming. In Pixies, you can just right click, move pivot, and then click on the solution that you want, whether it's center of the bounding box or a specific location in the world, and it just takes care of that for you. I'm applying this to a game object in Unity. It doesn't have to be the actual geometry. You can apply it to all the children if you want or not. So it's a really convenient things which can save you tons of time when you work with model inside Unity, specifically if you want to animate them afterwards, like Simon showed with the doors, for example, or the lift arms for this skid loader. So you can see there's a lot of features there, but amazingly, this is just a small fragment of what you can do with the Pixies algorithms. And if you need more granular control and to go deeper into your data preparation, then we have Pixie Studio, which Simon is going to cover now.
Yes, absolutely. And for those who are asking yourself right now, what did I do with that skid loader and his arms? Actually, I will show this right now, so don't worry, you didn't miss anything. I'm going to show the process of working with a skid loader actually right now.
Everyone is so eager, to know, and it's perfect that we are going to cover it. No spoilers here. We have, we want to keep you till the end.
That's true. And we will keep talking about pivots also. So, let's take a look at Pixie Studio. And Pixie Studio is kind of the big brother of Pixie's plugin, and it's a standalone application. So it can be used and is completely independent of the Unity editor. And it's also not part of your Unity industry license. And Pixie Studio is a great CAD data preparation optimization software, which usually helps especially our industrial customers to transform their CAD data or 3D data to any real-time 3D visualization scenario. So we again also talked about different use cases, and we chose 5 use cases how Pixies is used in the industry, or how Pixies, to be precise, how Pixies Studio is used in the industry. So number 1, you can use Pixie Studio for data review and data conversion. So you can use Pixies for simple CAD data review and data conversion, like getting data in, look at the data, and then export the data to a common format like FBX, which can be shared and consumed by other tools outside the CAD world. And Pixie's Studio is a great fit here, as it can import a huge variety of different formats also into one scene. It can render very complex and large data sets, and it brings built-in functions to review and export. Let's take a look. So when opening Pixie's Studio, you can import data in 2 ways. There's a guided way, and this guided way is actually the way that we would recommend you to use when you start with Pixie Studio, because he's doing a lot of operations that you need to convert CAD to mesh in a good way, like deleting unwanted informations, merging and repairing CAD services, it's tessellating the data, you're repairing the poorly meshed data by reconnecting edges, reconnecting vertices, and you also correct bad faces orientations. So I think for all of you who have actually worked with CAD data in any DCC tools, when you converted it to meshes, you know what I'm talking about, that usually this process can be quite painful because many errors can occur. So the guided import in Pixie Studio is a quite good time saver. You can also import a variety of formats, pretty much the same that Jerome showed earlier. And today I would like to import a SolidWorks assembly, which is referencing multiple SolidWorks parts. The import is quite quick, and as you can see, all my CPU cores on my PC are busy, so I'm really working in a multi-threaded way. The entire import of this model took about 46 seconds, which I think is quite fast, given the complexity of the model. And currently, with the medium quality that I imported, I have 400,000 polygons for now. If you come from a CAD or DCC tool, you will be quite familiar with the Studio's Pixie's UI. 3D navigation is quite straightforward. You can hide objects, you can move objects, you move with the Alt key on your keyboard. You also have standard operations like to measure. You can do sectioning. And for data review, I personally just love the exploded view because it helps me to easily understand complex overlapping data. So there's no need to manually move and hide objects. After the review, I can simply export my data into another common format. So I very simply created a conversion from a CAD data in a great mesh quality to a format that can be shared and consumed by my colleagues in the business. Use case 1. Use case 2, data preparation and staging for high-quality real-time 3D experiences. So let's assume that a visualization artist wants to create some high-quality output later with my data in whatever tool. So maybe for design review, for marketing, or also for technical documentation. So Pixies can import multiple CAD and non-CAD data sources into one project, and it provides you the flexibility to manage the data and its metadata directly in the product key. So you can have even access to the parts, to the patches, and even to individual polygons. So let's grab that data in Pixies and leverage its tech to generate a very high quality mesh. To have more control, you go for the raw import, which means you have control, but you also have to do more manual steps compared to the guided import. So after you import your data, you can just see your BREP, the boundary representation of your CAD data. There is no mesh yet. Before you start the tessellation process to actually convert that BREP, that construction data, to a mesh, please make sure that you execute the repair CAD function to really make sure that the CAD services are repaired. So you can go to the menu for CAD, repair CAD. And usually I would recommend to start, and Jerome mentioned earlier, right, with a medium quality. Always start with a medium quality if you're unsure, if you don't have predefined values, and you get to a pretty good quality initially. And now you can just analyze your geometry. So I have 400,000 polys, but taking a look at my edges, it's okay, but I'm not really happy with the quality. So I'm changing my quality to very high, which is changing the sec value. And the sec value defines the difference between the BREP, the original data, and the polygon data. And you can clearly see the difference between the medium and the high quality data. Keep in mind, the tessellation and retessellation also works on individual parts and doesn't have to be applied to the entire scene. And I can do this at any time in my entire process. So let's also talk about UVs. Pixies provides two ways of generating UVs. One is three-dimensional projection, so where you technically project from top, side, and the bottom. And Pixies is smart enough to just create UVs in a world scale texture size. So technically, all the UVs, all the squares on my UV layout are equally high, equally tall. But you also can see some distortions from a three projection way. So you can also use the UV by unwrapping algorithm to unwrap your geometry to generate UVs in a higher non-distorted quality. After that's done, I can use my geometry later in the process. I can apply textures to it. They will look evenly and they will work. And also I can work with backlighting just whenever I need to store lighting information into my UVs and mesh, then UVs are absolutely mandatory. I also need to do quite often when I prep data for high quality purposes, I need to do some visual decision making. So for example, you might have noticed in my scene that I have wheels and tracks at the same time, which doesn't make sense. So in Pixies, I can logically create occurrences in my product structure and put objects in there. So I can change the product tree. I can also make objects visible or invisible, or I can define the visibility status to be that inherited from the parent or to be independent from the parent. So even if the parent is hidden, my objects can be visible, which is quite handy to have control over complex datasets. And Jerome, you gave a sneak peek already. As the model might be animated or even driven in the future scenario, I need to define transformations of my parts. So in Pixies Studio, I also can work with pivots, and I can rearrange the product structure in a way that I can apply transformations in a logical way. As we can see here, we adjusted the pivots, we readjusted groups. So later on, I can just lift up the arm of that skid loader in a future scenario, which can be Unity, but also can be another application. A powerful feature of Pixies is also the ability to handle material assignments and metadata. So Pixies is probably not the tool to make final shader adjustments for rendering, but Pixies is quite strong in handle part material assignments. And Pixies is super strong in reading, editing, and creating metadata on top of geometry. As Pixies can output also data in an agnostic way, the material assignment of the metadata can be used to exchange materials with a lookup table, like here in Unity, so we can automatically replace materials to apply the perfect look of a model automatically. Use case number 3. Data optimization for mobile real-time 3D experiences. Let's assume I would like to optimize data in a way that it can be used by mobile platforms. So it must be optimized to natively run, for example, on a smartphone, on the web, on a headset, maybe an Apple Vision Pro, or, and many customers are using this, on an embedded system. Like how can actually this model run in a car? So Pixies has performance tools to quickly decimate and optimize data so it can be handled efficiently by mobile platforms. So what does decimation optimization mean? It means that we have to match the target requirements of a certain platform. For example, if it has to run on the HoloLens, I should not use more than 30,000 polygons with a medium complex scene with a couple objects. When working with the Quest or the Quest 2 or some desktop VR headsets, obviously I can work with way larger poly count. However, I always need to know the target criteria of the polygon count that I want to achieve. So let's just look on how Pixies can answer to that requirement. With Pixies, you can do decimation. So to perform data decimation, you don't necessarily have to work with the cut data. Well, of course, having the CAD data is probably best because you will have the advantage that you can use the NURBS data as a reference. However, I mean, let's be realistic, right? There might be many cases that you don't have access to the original CAD data. So the great thing about Pixie's tech is that the tech is working so good that you don't necessarily have to have the original CAD data. A high poly is perfectly fine. We can see the difference here right now. On the left side, the source is a CAD. Here the source is a mesh file. And just by the wireframe, we almost don't see any difference. And also by the outcome geometry, it pretty much looks the same. So Pixies offers many functions to decimate data. Depending on your expectation on quality, you can spend 1 minute, or you can also spend 1 month on a complex data set. 1 minute, you press a button, say, poly count 100,000, that's 1 minute. Or you say like, okay, I have 1 month, I have a very complex data set. Maybe it's like it's a yacht or a ship or a building or a complex car. And I would like to have the highest quality running with 10,000 polygons or 20 or 30 or so. So I really have to spend a lot of time to make that happen. Be aware, before you start the decimation, make sure that you have a repaired mesh, as stitched mesh will always react better and will not produce any cracks. Obviously, if surfaces are not connected, then there will be holes later on and the decimation will not work so good. The fastest route to decimate poly count in Pixie Studio is to decimate to target. So technically, you are reducing the mesh density until a certain poly count is reached. Here we can see the quality difference in detail. It's technically a one-click solution to go from 100%, 70%, 50%, and lower. So to go from millions to thousands of polygons. Decimate to quality preserves more of the visual quality of the model. So technically, it smartly deletes vertices using quality criteria to prevent smoothing artifacts and topological irregularities. Okay. Again, try to start working with a medium quality. And this also changes the surfacic, I really can't say that word, the surfacic tolerance.
Surfacic.
Surfacic, it's a French word, I guess, right? Surfacic tolerance, which, like the sec value from before, defines the distance between the original tessellated polys and the new generated poly. And you can generate a higher precision for the curve. Remove holes. Another fantastic feature in Pixie Studio is to remove holes. To execute it, you can re-identify the patches on the mesh. So even if you have the poly information, you can re-identify the cut information. And afterwards, you can perform a remove hole function on it, which is removing the holes on your geometry. After, again, decimating it to the same quality, you can reduce the poly count from something which was 2,800 to 80, which I think is fantastic with just a 2-click function. Besides decimation and removing holes, there are a lot more functions in Pixie Studio to really optimize data for real-time experiences. Number 4, automate the data preparation and automation. So, I mean, let's be honest, we have seen a couple of use cases of Pixie so far, and for some, human decision-making is needed. And it's also required because my process probably isn't so far that I can do the optimization already. However, many things can be automated, and Pixie is made for automation. And Pixie's scenario processor is a tool to batch execute pretty much anything. So for every function in Pixie, there is a Python command. And it's very straightforward to capture a sequence of actions to batch execute it afterwards. Let's take a look. So imagine I have the same geometry and I would like to remove the holes in your scene, afterwards decimate it to a certain quality and adjust the pivot. So I again can go to my remove hole function, but instead of executing that function, I just copy my Python code to clipboard and can paste it to my scripting window. I do the same thing for the decimated quality. I copy my Python code to clipboard. And afterwards, I want to do something else. I can search for any function in my functions window, for example, like centering the pivot, and you might guess it, copy the Python code to the clipboard. After my Python scripts are in there, I can press the play button, and all 3 actions will be executed automatically, sequentially after each other. So technically now, I can just save my script, put it somewhere else, and load it on demand. The question is that the smartest way to really deploy scripts in my tool? Probably not, right? So Pixies also offers the so-called Pixies well, I shouldn't say it, right? Pixies offers plugins for Pixies. Remember, we talked about the Pixies plugin, which is a plugin in the Unity editor. But in Pixies, we also have plugins. Don't get confused. So in Pixies
Studio, you also have plugins.
Yes. So in Pixies, you can create, in Pixie Studio, you can create and install plugins. So technically, you can add your Python syntax directly in here. You create them, and afterwards, you just add your Python syntax directly in here. You can make modifications. You can save your plugin. And now you can easily execute the predefined scenario script in your menu bar by just executing the function. So you go to plugins, choose a name, execute it, done. Technically, the same operation is done with like a one-click solution. So using that way, it's a great way to streamline and customize your own workflow, but also help your colleagues also to optimize the workflow in the business. Well, seamless automated data conversion is possible with Pixie's Scenario Processor, another tool, right? We have Pixie's plugin, we have Pixie Studio, and we have Pixie's Scenario Processor. And Pixie's Scenario Processor technically is an application which is like a Pixie Studio without a user interface. So it needs to be driven by Python only. So you can execute and run your Python recipes directly in here, and you can run data operations without using Pixie Studio, and you can save your data pretty much anywhere. So you might have noticed I just converted this high quality FBX file of that skid loader to a low quality version of that skid loader. So if you want to make the best out of both tools, you can just save your recipes, your scripts from Pixie Studio. Afterwards, you have this script independent already of Pixie Studio. It's just a collection of different scripts. You can make changes, adjustments, for example, add multiple outputs. You can change the names here directly. And afterwards, you just need a way to execute that script. And for that, I'm just using a batch process. So I'm just creating a batch file. And this batch file technically is starting the scenario processor exe and then calling the script. Ideally, you implement this into an application in a web front end. You might create a watch folder. In this case, I created a batch file. Either way, in that scenario, I automatically converted my FBX file to 3 different output formats, leveraging Pixie's scenario processor. So I think you can use scenario processor for any use case in your business to accelerate and automate data conversion, but also preparation and optimization. All right, number 5. Let's look into the future, and let's talk about the asset manager that we have seen in Unity editor earlier on. So in a future version of Pixies, which is planned to be released this summer, we enable you to save your assets directly in Unity Asset Manager. Technically, you can do this today, just using the Python API in Pixies and the API of the Unity Asset Manager. But why would you do this? I mean, wouldn't it be great to just store data, not only to disk, but store it directly to a platform so that others have direct access to the right data? Or wouldn't it be not fantastic to directly modify an asset and experience the updated version seconds later in an end-user application, maybe on a smartphone on the other side of the globe? I mean, in Pixies 2024, there's a function to upload a scene to Unity Cloud. So you can log in there, you can choose your organization, your project, and you can add the current data as a 3D asset that runs on the web directly into Asset Manager. So currently, this video is running in real time right now. So this is how fast it's taking. It's just seconds to convert this complex data set to something which can be used in the cloud. And afterwards, the data is uploaded to the cloud. I can review it and preview it directly. I can understand what data I'm talking about, and I can easily deploy and scale the access to the 3D data throughout the entire business. What do you think, Jerome?
I think it's amazing. I love the convenience. Oh, well, thank you, Simon. Now I shall grab the share again. And this is my section. So I love Pixie Studio. I use it pretty much for all my projects. But as Simon highlighted, right now the workflow is, especially for automation, is a little bit dissociated. You have to edit that script, for example, in Notepad, because we don't have technically a Python plugin that you can add in order to work with scenario processor. Some of the functions that are available in scenario processor, like the batch input and output, are not available in Studio. So it makes the workflow a little bit dissociated, although they work well together. It's not necessarily ideal. And this is, again, that's why we had this statement at the beginning of the presentation. This is a new product that's going to be released later this year called Pixies SDK. And what is Pixies SDK? Well, it's actually a seamless way to integrate Pixies in your infrastructure and making it easier to develop Python-based or C#-based scripts and integrate them in your existing pipelines, right? Without having to use monolithic tools like Pixie Studio or Pixie Scenario Processor. It runs directly inside the Python or the .NET environment, and you can integrate them a lot more, integrate the Pixies functionality a lot more easily. It's also the backbone for all of the tools that we're going to be releasing around data transformation at Unity. That includes Pixies Studio 2024, the upcoming release. Pixies Plugin 2.0 is also based on the SDK that's already available for industry customers, and the Asset Manager, the transformation. So when Simon showed you drag your CAD or BIM file directly, or FBX in the Asset Manager, for example, in the web interface, it would generate a GLB preview that is using the Pixies SDK in the backend, right? So it's really a way to industrialize solutions around the Pixies algorithms for your own internal company usage, right? Again, multiple APIs. Currently, Studio and Scenario Processor are only Python, so we're keeping Python because it is, de facto one of the most used pipeline too. But I have customers, for example, which are on .NET, and we now have a C# API they can use in order to integrate Pixies directly into the infrastructure without having two environments to execute code in. Also, it includes all of the file supports that you already have in Pixies, right? All the goodness. All of the algorithms that are available in Studio, plus the ones that are exposed as part of Pixies plugin. And it's meant to be deployed locally. So if you're in an airtight infrastructure, for example, like most industrial are, you can run this on premise or in your own infrastructure or in your virtual private cloud, or if you want to use, for example, cloud-based infrastructure using Docker images, right? And I'm going to switch to a live demo because I don't get paid unless I go live. So here is PyCharm. Yeah, that's a Python development tool that I discovered recently because I was mostly a writer type of person, since I'm mostly doing C# development with Unity, and it's also by the people that are making Rider. But if you were working in .NET, you could use Visual Studio or Visual Studio Code if that's your jam. But I use here PyCharm. I have imported the Pixies SDK. I have added it to this project, and I now have direct access to all the Pixies goodness. Everything else that you see is standard Python development. If it's the first time you see code or Python code, that might be a little bit scary. But if you're a visual person, you have obviously Pixie Studio to help you with your data preparation. If you're doing integration inside a continuous integration or continuous delivery pipeline, then this is something that you would be familiar with. I have a couple JSON files that I've created for this project, and I can click to see what's inside. It's basically some custom configuration I created, right? There's no standard way for you to manage this. It works with whatever you want to use. Here I'm using JSON, and I define basically the source asset. As you can see, it's a solid work assembly. My source output, the asset manager, that's why I separated them, has this concept of source file. So that's the file that you're going to upload when you create a new asset. And that's the one that will be, for example, available inside the Unity editor when you pull that asset from the asset manager. So in this case, I'm going to create 3 source files, just like Simon was showing with Scenario Processor, except I'm using an FBX, a GLB, and a USD, and I forgot I'm going to start the script where we do this because it takes a little while. So you can see in the command window here in the console, what's happening. We're opening the file, right? And then I have an optimized version, which is going to generate a GLB and a USDZ directly within this script. If I go back to my script, here I have my license information for Pixies, pretty straightforward stuff. And then I have 2 recipes that I'm using. One is to generate the source file. So I'm going to go into this. This is a class that I created, right? Just to kind of create good practice and reusable code. So here I'm doing a repair CAD. Simon told us always do repair. So I'm doing repair. And then I do a tessellation using a pretty low value for MaxSag, which will give me a nice definition on those curvatures, right? Following like a nice surfacic quality, as we mentioned before. And then once I have prepared my data, I just export it as GLB, or the 3 extensions that I defined. You can see it's kind of like syncing with what I'm saying right now. Then I'm creating the optimized version here. So this is a little bit more advanced when it comes to using the algorithm. So I'm going into the product structure, I'm finding occurrences, for example, the fork assembly, the brush cutter, the sweeper. I'm looking for some of the engine compartments, and I'm adding that to a list that I'm then gonna, brutally delete from my model because I don't want to keep them. And then finally, I do some tree cleaning, removing the empties, raking, compressing the tree, merging by materials, and then doing my tessellation with a much higher MaxSag, so I don't have that much mesh data. And then I export them. And you can see here in my output folder, magically, 5 files appeared. These are my 3 high definition or high density meshes. And then these are the 2 that are optimized, right? I can go into Explorer. There we go. And we can see here, we hide this, the files are available on my hard drive, right? And I can work with those. So all of this happens inside the environment. I don't need to switch to another tool. I do it all within PyCharm, or then I can export this as a Python code, for example, or as an executable if I want to hand it off to someone else. But it's all self-contained, coming soon for you to explore and use. I also wanted to mention the next logical step, and we're already almost at time, so I want to leave time for the Q&A, is the integration with the Unity Cloud API. The Unity Cloud API has 2 main API that you can use, especially for the asset manager. There's a REST API through the web portal, through the web directly, or a Python one, which is super easy to integrate in this project. And if we have time at the end, I can walk you through doing the same process and then pushing to the asset manager, but we'll see. And I think that's it for our session today. It was a lot of information already. Good news is episode 2, you can already register for it. Be mindful that although there's 4 episodes, you have to register for each individual one. Just scan this magic QR code. I know we're using the latest and greatest technology at Unity, so you can go there directly to the registration page. Obviously, it'll be also probably indicated in the follow-up email that you receive. We put some information that will be in the follow-up email on Unity Industrial Success with Rebecca and her team. And all the tools that we covered today, including the just newly released Creator SDK, which compiles everything that Simon mentioned, from annotation, metadata, presence, deep linking inside the Unity application. We unified all those SDKs. You can find all the packages directly on this page here, including the cloud asset, which allow you to pull the asset manager assets directly into the runtime. So there we go, superpowers. And now we're going to go into Q&A. Woo!
Yes, we have had loads of questions throughout today's session. I also want to do a special shout out to Laurent, who is our senior technical product manager for Pixies, who has been absolutely bossing the questions in the Q&A, meaning that we've actually answered quite a few. So yeah, if you do have any more questions, just please drop them in the Q&A chat. There's just a couple questions that actually I wanted to kind of drop into for both of you. Because in terms of kind of using Pixies as well for kind of like workflow, how would you recommend like best practices for updated CAD data, which is kind of a common occurrence for a lot of kind of CAD content creators, is dealing with kind of versions and stuff like that? Do you have any recommendations of how to utilize Pixies in that process?
Yeah,
Either one.
it all depends on the process. If it's fully automated, then I would say right now Studio Scenario Processor is your best friend. Define the recipes and then automate them with Scenario Processor. There is a great little sample that Simon was using, which is the folder watcher, which allows you to basically just monitor a folder, drop some files in there, and then automatically trigger a Python execution that will then start Scenario Processor and run the scenarios that you have. So that's one way to start automation. You can go further by connecting directly to your PLM or PDM in order to have automated updates. We have customers that do that too. So that pipeline automation is really powerful. And then, you could also include in there, for example, if you Pixies plugin and then the build functions right inside Unity are sufficient for you, then you could do that also to automate your workflows, right? So that's also a possibility depending on how you have set up your backend. Simon, you may have some more options or ideas.
I think you mentioned it. I mean, generally, it's always about the process. What is your process? I think it's just important to have like fixed components of this process ready. And I think we are providing right now these bricks and foundations actually to just enable you to make this process happen, such as Pixies technology, which might be used in Scenario Processor, but it also can be used as a part of Unity Cloud. We provide Asset Manager also like as a single source of truth or place for the single source of truth where this information can be stored. So I think for us, it's providing like different components that can you connect together in a way that it's fitting your workflow in the best way.
Awesome. We've actually had like quite a few questions actually come in, specifically, I think, from Jerome's demo concerning point cloud data, and kind of bringing those into Pixies. Do you want to kind of like run through in more detail?
Oh, sorry, what's the
just
I think there was
Laurent. There was a question and Laurent has just grabbed it from my view.
Laurent,
so it's
Laurent
been answered in the chat.
I think Laurent was the third or fourth person that I've met when I went to my first Unite back in Berlin, Laurent, on the Pixies booth, which was, not yet part of Unity. So he's a star when it comes to Pixies.
I think it was more the beer garden where we met Joe, but anyway. Yeah, there were a lot of.
This is being recorded.
There were a lot of questions around point cloud, so try to remember. But yeah, you can import multiple type of point clouds within Pixies.
Yes, including Recap, right? You can connect to the Recap SDK if you have a license for BIM and specifically architecture, which is that's a very popular technology. But basically, whatever you can do with mesh with Pixies, you can apply to point cloud. You can actually create meshes from point clouds if you want to reduce the complexity, for example, although they're pretty efficient if you segment them well. And obviously, the segmentation is key to optimization so that you don't send vertices of a point cloud that don't need to be rendered. And if you test that with the latest version of 2023.3, which is in alpha in the hub, you should be able to tap into the GPU culling, which should really, really optimize this type of rendering. Same with what Simon was showing, like this very complex USD data set, for example. Individual objects which are not visible will be called way before, much more efficiently than the current system.
Yeah, I think in general, if you get the chance to go to the first alpha or the beta of Unity 6, it's really promising on what we see in terms of performance when handling large scenes. I just recently imported a huge factory facility with millions of triangles, and just by leveraging newest technology like batch render groups and also using occlusion culling, you just increase performance in that scene I think it was from 5 to even 50. So by a certain factor, depending on the scene. So just by using functionalities in the scene. So I'm really looking forward to working with future versions of Unity.
And here, while Simon was presenting, and I swear I was paying attention, but I was also running this remeshing algorithm in Pixies to generate a little physics mesh for my point cloud. So you can see now this physics mesh kind of loosely follows the point cloud. You can obviously optimize it further. I just went for something quick, but that means that now, I'm not able to penetrate inside the point cloud. I have to stay within the bounds. So again, one function that you can have in Pixies, which is really, really convenient. It's conscious that we are time, so maybe a couple of last questions. We're good to stay, but as long as we don't get kicked out, maybe we can finish the questions that are in the Q&A.
Oh, just looking through. Just making sure we can answer those live. I think just as kind of like a reminder, we will be following up with some people via email. So we're going to be reaching out to you guys. If there is a question that wasn't being able to be answered live, we will definitely jump on. I can see a couple have just popped into my view in the chat.
Oh, I can see in the Q&A pod, there's a few here actually. So about consuming IoT data in Unity, MQTT messages. Yes, what's on GitHub. So the .NET, the MQTT.NET implementation for Unity is what I've used in Road to the Metaverse. We have a section on IoT. Yes, it's not a Unity verified solution, but these are pretty popular projects. So there's a lot of contributors. It should be pretty solid, and it's based on the MQTT.NET implementation, which again is also a very mature package. I would say, just because it's not a verified solution doesn't mean it's not a good solution. For example, GLT Fast, which is now the official package for GLTF in Unity, was a community project. And also the MRTK3 is a community project with hundreds of contributors. So check the stars, check the contributors, and then you should and also they are open source. So if there's things you need to debug, you have access to the source code for these packages or these features. So it should be pretty good. I'll mark it as answered.
We just got like a quick question just regarding kind of Pixie Scenario Processor, of course, has been going through a lot of development and obviously moving into that Pixies SDK. So I guess, yeah, it's going to be about resources. So yeah, those will probably be upcoming when we do fully release the SDK. So you'll have that as that is kind of an evolution of the scenario processor.
Yeah, I would say that they're two very different products. They might kind of evolve, or they have overlap, but Pixies SDK, although it's not a far departure from Scenario Processor, it's kind of a different mindset when it comes to deploying Pixies. So rather than have this centralized process where you pipe all the information through, which is Scenario Processor, you can now embed Pixies wherever you need it within your infrastructure. So it's much more flexible. And really, when you're looking at scaling, especially in elastic infrastructures like, virtual cloud-based processing, it's going to be the way to go. But obviously, if you need to get started today, I really encourage you to check out Studio and Scenario Processor, especially Studio, because this will give you an idea of just the power of Pixies. And as Simon showed, that interactivity visually for a lot of tech artists specifically is quite important. Then when you go into automation, Scenario Processor and Studio work really well hand to hand. And then, later on, as a standalone solution for integration into pipeline, Pixies SDK will be the way to go.
I can also just go for the question about digital twins. So the question is, Unity industry have any possibility of kind of a online digital twin manager? So technically the answer is like before. I think we try to provide like different components of technology that makes it possible to work with digital twins. So we want to make sure that you have ways to convert your data, to store your data, to run the data also later in experiences, and also be able to connect to different systems and data sources in real time to actually not only have like a static digital twin, but also feed your digital twin with real-time information. And at the same time, as we are also investing into AI technology, we also would like to provide tools and technologies of just like making it possible to simulate scenarios for digital twin use cases. But again, there's not this one single digital twin manager. We rather provide technology to enable you to realize that.
Awesome. Also a question about CPU versus GPU, and what was said, the latest version of Unity, which will become Unity 6 when it's officially released, normally at the end of the year, has a new batching and culling system, which is GPU based, contrary to the current system, which is normally calculated on the CPU, just like our physics. This is going to be much more efficient. There's a session at Unite which highlights some of the key features. Simon also mentioned that he's been testing it specifically with large data sets, right? Especially instance one. So it's very, very efficient. On the forums, there's been a lot of contribution from the community and people mentioning that what used to take them hours to optimize, they can now basically click a checkbox and it works automatically. So really, really big improvement. And we're keen to see industrial customers test it with their data sets because they're a little bit specific. So it will be really interesting to get your feedback, especially if you have an industry license, reach out to your PRM. Do we need to create a program process for every model? No, you can basically have generic process for scenario processor or within Pixie Studio if you're manually opening the files. Just like, I showed with the, for example, repair card and tessellation, that can be done for any type of files. And if you have file-specific things, like, objects with specific names that you need to work with, and yes, that will be specific. If you're using metadata, you can query the object's metadata, for example, in Studio or in Pixie's plugin, Scenario Processor, or Pixie's SDK. And based on that metadata, you can apply a specific recipe. You can assign a material, right? You can work, or you can even augment the metadata with custom metadata that you then use inside Unity, for example. So you have that flexibility. Obviously, if you start working with objects with specific names, etc., then it's not going to be a generic process. It will be quite specific, but you can stay quite generic with the process depending on what you're doing with your file. So it doesn't have to be one scenario per file. Then I think, Simon, you're answering one of the question about Unity Industry, and there's some asking about FBX security vulnerability in Microsoft. That's unfortunately that's outside of our kingdom. There's not much we can do other than suggested using GRB, GRTF, which has limitations. But if it's between not using anything because FBX is blocked and using GLTF, I guess it's the lesser of two evils. There's OBJs also, which could work, or USD. I'm assuming that USD should have good animation support. Simon, maybe you want to comment versus FBX. I'm not sure.
I mean, again, it depends on your workflow. I think FBX is kind of the standard format in Unity, which is there since years, which is kind of the industry format, which is proven. Formats like USD for some agencies and for some companies are replacing FBX as it provides more and more functionality. I think we at Unity, we kind of think that it's not one format, it's multiple format. It will always be like a diverse system. I think the big value of GLTF really is its status as being like the JPEG, right? The JPEG of the internet. So technically it works everywhere. So I don't really see a direct competition to an FBX or to other file format. It's like a format which is great for a specific use case, such as USD also is. There also is a question, how does Pixie's Unity and Revit integrate BIM models within Unity for augmented reality? I think importing BIM models coming from Revit is something which Pixie's plugin or Pixie Studio can handle. So if you want to directly integrate it into your Unity process, you can work with Pixie's plugin. If you have like a dedicated process to just convert your BIM or Revit data into something you want to reuse, maybe in Unity, maybe in a runtime, and maybe in another tool, Pixie Studio or Pixie Scenario Processor can be used to do that. And then later on in Unity, you just make sure that the model is working in the best case in an augmented reality scenario.
Yeah, we showed in the little demo that actually Pixie Studio, for example, Pixie Scenario Processor or Pixie's SDK, sorry for all the names, but there's different products here. They can all export USDZ, for example, which you can, on any iOS device, visualize with AR Core or AR Foundation. AR Kit. the native stack from iOS. So, super convenient. If you really want a fast pipeline, then you can go through the Unity editor if you want to, for example, export Unity specific file formats like asset bundles and things like that. Or, just export a GRB, which should be viewable with most AR systems cross-platform. It's really pretty straightforward, but yeah, you can work with any BIM models, Revit file or else within the Unity editor and really get some good results for your projects.
There's another question from which is about the integration of digital twin, collecting and reading into from a factory floor. How reliable is Unity running continuously long term? Does not crash? Has this ever been an issue? So I think
so
fantastic
to ship
question.
software is to ship bugs. So that really depends on who develops the application. You can put fail-safes in there in order to do memory management and and try to recover from issues. If you integrate external data sources, that's usually the open door to issues. So it's as stable as you want to be. Unity is used in extreme environment, right, Simon?
Yeah, we have a great example right now that Unity is used by the Vancouver Airport Authority. So technically, the entire information of the Vancouver Airport is collected and brought together in Unity. So Unity is used like as a visualization layer of bringing that data together, and it's actually used. So if Unity as a system is running on an airport, where we really have a lot of security requirements of actually presenting the right data at the right time, I think you can make it possible that Unity is running as a reliable system, but Jerome, you said it perfectly. Well, human errors obviously the human has to make sure that its integration is as reliable as possible. But from a technical point of view, Unity is used for that, yes.
Yeah, I think also just to
yeah, great. Sorry,
so yeah, just to chime in, yeah, we do have see a lot of use cases of kind of real-time operational apps as well. But yeah, it is definitely a case of kind of going almost back into it's humans who create digital models. So it's kind of going back to how clean those models are, how heavy those models are, and hence why Pixies is great to kind of help bridge the gap to kind of make those as performant as possible. Yeah, I'll pass back, Jerome.
No worries. Yeah, and we also have usually a lot of issues come from memory management, and historically that was quite obfuscated in Unity with the Mono and .NET frameworks. But you now have access to what we call native memory, so you can allocate your own native memory stack and really manage it as you want to. So if you need to create very security or very sensitive applications, right, that shouldn't crash, just like it happens, for example, with our car manufacturers that are embedded Unity in their infotainment and cluster, right? They're really focusing on stability there. There are ways to create Unity systems which do not allocate memory, and will make sure that you don't get, overflows of that type, right? So it's possible, definitely. All right. Well, we're almost at 50 minutes after our official time. There's still 100 of you, which is fantastic. So I feel like I should probably do, first of all, a thank you to all of you who stayed so long and for this first episode. And then as a little treat, quickly, 5 minutes, I'm going to go into the overtime and show you Pixies SDK with the Unity Cloud SDK. So what do I mean by that? Inside my project here, which I showed earlier with Pixies SDK, I have an advanced script, which has a few more parts here. You can see the Unity Cloud integration, which allows me to connect directly to the asset manager. And I believe I should have a window here, if I exit my slide, where you can see this is my project with workflow demos. There's nothing there. So while I explain what's happening, I'm going to start the script. And hopefully it all works. You've seen this before. I have a skid loader configuration, right, which is going to export 3 design files and 2 optimized files. That's the same as we did before with the simple. Actually, sorry, I'm executing the simple script. So I need to stop this and go to the current file, which is my advanced one. Thank you. And run the right script. Let's go. So I have the files already generated here, but it's going to regenerate them. Again, same process as before, generate the source files, generate the optimized file, and cache them here into 2 lists that I can use later. And here is the new code where I'm going to connect to the asset manager. I'm going to create a new asset on the asset manager using the name and description that I define in my configuration here. And then I am going to add this asset and grab the list of datasets. So it's kind of like folders that you have. An asset is made of datasets, and those datasets can have assets inside, like files. I'll grab the first one in the list, which is the source, and I'm going to upload basically the FBX. That's defined here. That's the first one on the list. Why do I do this? Well, that's the file that Simon will see, for example, in the Unity editor. The editor can pull FBX by default. If I made that the GLB or the USD file, then it would sit there and it wouldn't be imported unless you have the right packages. So for safety, I put that as my source file. And then, because I'm bold, I decided to create 2 specific datasets for me. So there's a design file where I upload the rest of the source file. As you can see, I removed the first one from the list and then upload my USD and high density GLB to the asset manager. You can see the optimized files are finishing to update. And then I have also an optimized file folder that is going to be pushed. And now you can see through the magic of the console that I'm pushing to the asset manager from this Python project. No trickery here. And it's uploading the first asset. It's going to do that 5 times because there's 5 assets to push. So it takes a few seconds. But yeah, this is basically when you want to integrate this type of algorithms within a pipeline, as some of you asked earlier, this is really the easiest way to do so. It's very, very powerful. And what I love is the ability to just work within one environment, right? And getting it all done. So where are we now? We are uploading some of the assets. Oh, yeah, we are uploading the full USD file, which my internet is a bit slow today, actually. Normally, it's a bit faster than that. And now we're going to go to the optimized file, which should be faster because I think they're 4 megs each. There we go. And lo and behold, there we go. We're done. So let's go back to the asset manager and refresh. Live again. There we go, asset manager is coming. And look at this, we have a Unity skill loader. I think that's the first one one of those is the first one I started because it creates the asset, but you can see there's no files in there. And then this one is the one with the source files. So you can see there is a the FBX, which is about 70 megs. Then I have design files in there, which has a GLB and a USD. And then I have my optimized files, right, which is my GLB and my USDZ. And now if you were to go to, for example, the Unity editor and go to the asset manager, it's going to refresh. And there is my skill loader. It's right there. And I can import it into my project. So I can be working on this on my machine or in my infrastructure, and then automatically you will get that updated file. As you can see, the asset manager is doing its thing. It's going to create the previews in a few seconds once the processing is queued. So yeah, so that was my little overtime demo. Just a little nugget for those of you who stayed a bit longer. And I think that is it for us today, unless Simon, Becca, you have anything else to add?
No, just thank you for everyone for sticking to the end and getting an extra treat for seeing that demo.
All right, there's still 90 people. Who's gonna end the stream? Someone needs to end the stream. I'm not in charge, so everyone, thank you. We'll see you on the next episode. Thank you again for sticking around and all your super good feedback. Really appreciate it.